What's up, everybody? Welcome back to the podcast. Now, 2026 is here. So first off, Happy New Year. And we took a break from publishing podcasts for the last couple of weeks of December. There was a lot of people not available to chat. And you know what? I had to decompress myself. So hopefully you guys were able to do the same over the Christmas break. Now, we're going to get into this discussion with Sal Randisi. He is from Superlube and Croyle. Now, Sal's got lots of experience in the lubrication side of the business, and he can break down a lot of the educational parts. So that you don't even know how in-depth lubrication is until you speak to someone like Sal and get the lowdown. But he's going to bring value from the educational side. And we're also going to talk about some products in different scenarios that will help, like if you're breaking apart a bolt or you're lubricating a bearing, something along those lines. So this is part one with Sal Randisi from Superlube and the ever-loving Croyle. So let's get to it, guys. This is the HVAC Know It All podcast, and I'm your host, Gary McCready.
This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out.
All right, Sal, I'm excited for this conversation because we got a bunch of lubrication discussion to go through. One of the things that I've been doing for many, many years is lubricating like bearings in motors and sort of isolated bearings on blower shafts and stuff like that. And I know we're going to have a discussion on stuff like that as well through the conversation. So, hey, you just go up there and just slam a lubrication into that exert fitting. There's a bit of a science behind it, a little bit of a technique and all that kind of stuff. So I'm going to give you the floor, and you can start where you want with this conversation, and I'm sure we're going to get to a bunch of points that we'll touch on for the audience as we go here.
Well, I appreciate it, Gary, and thanks for having me here today. I'm not a HVAC professional, but have a lot of end-user experience in applications that include HVAC, but a lot of industrial applications as well. So we're used to going into facilities, whether it's a large manufacturing facility or any kinds of other factories, and really trying to help bring value to the lubrication world, save the customer time and money. But maybe a good place to start, what is a lubricant? I think that's one just to get a ground floor. And then maybe I want to touch on some of the chemistries of lubricants. So maybe listeners have a better idea of what's in them and why they're being used. But, lubricant could be a substance, it could be a semi-solid, even a fluid, right? An oil. It's meant to be put between two moving parts to reduce friction, heat, and wear. So if this happens, the piece of equipment or the part, the life's going to be extended and last longer. People, when they think of lubricants, they just think of it as, okay, let me just add some lubricant. But this is a real engineered system. This is chemistry. Companies spend a lot of time and money trying to make products that will provide value to users, people that are going out there every day. And, equipment costs a lot of money. So, when a lubricant fails, it's not really always the base fluid oil. It's a lot of times it's the chemistry around it, or it's many times incorrect lubricants being used for the application. So we find this in many, many instances where they're not using the correct lubricant. And, a simple example is Southern California. I know you're north of where I live, so there's plenty of reasons why you need a low temperature lubricant in an area where you're located. But in Southern California, it's sunny, so there's not a lot of moisture. Obviously, there's no rain. The temperature is pretty even. So we had an application where these were fire truck ladders, and they were not using the most expensive grease, but the grease just kept on breaking down. And every time they tried a new grease, it would continue to break down. So we went out there and why is the grease failing? It's so nice out. There's nothing preventing it from failing. And I said, well, the main reasons for failure in Southern California is UV. The sun will dry the oil out of the grease. And while they thought they were doing a good job, the grease they were using, they literally had to take a wire brush to it and scrape it off. So I think that's something where just trying to understand the environment around you is very, very important, and understanding why a lubricant's being used where, maybe touching on some of the lubricant chemistry. When you have a motor oil, gear oil, those types of products, you're going to have a base fluid oil. So the base fluid oil can be petroleum, it could be synthetic, it could be natural, some kind of, biodegradable, could even be silicone. And what they do then is they add a bunch of additives to really, make that oil be better than what it is for the application. So they're going to add antioxidants, viscosity modifiers, anti-corrosion agents, tackifiers, foam reductions and dispersants. In a hydraulic system, you need an anti-foam because it's a very violent system that moves. So you need to prevent oxidation from getting in.
So what we can say, just want to make a comment, you can tell me if it's wrong or right. We're adding a bunch of additives to either synthetic or like petroleum-based stuff in order to make it work correctly, is what you're trying to say, right? Basically.
To work correctly and extend the life. So as an example, people say to me, there's already an antioxidant in the product and there's also a corrosion agent. Well, aren't they the same? Well, no. An antioxidant is actually used for the actual oil or grease itself. The antioxidant will prevent what they call free radicals. As the oil or grease breaks down, acids begin to build, and those acids slowly will degrade or reduce the wear and efficiency of the lubricant. Corrosion agents are actually meant as a surface barrier to the surface you're lubricating. So as an example, if the corrosion agent breaks down and the antioxidant is breaking down on the lubricant, you're going to have wear. And if the grease oil starts breaking down because of the antioxidant, your corrosion inhibitor is working well, you're still going to extend the life. So these are very delicate things that have to go into trying to understand what the balance is in making a product like this. So when you use a product that has proper chemistry, it's a really, really good thing to see when product does what it says it's going to do.
Yeah, for sure. Now, I know you probably have some information or some knowledge or into greasing a bearing, and I don't know if this is part of what your notes have for this conversation, but I'd like to just go to that for a minute because there's a lot of things around this. And one of the things, I want to bring this up because I've seen it lots, where you can have like a pillow block bearing and it may have a Zerk fitting on top, a cap on top where a Zerk fitting can go. But a lot of times the bearing is sealed already. Like there's no way to actually add lubricant. So some people are pumping lubricant into the top of the pillow block, like fitting, which is usually like a cast iron. And because the bearing's not designed to accept any grease, it just actually just oozes out the side of it. Because there's a difference between a bearing that's permanently lubricated and sealed and a bearing that needs to have lubricant added to it, like periodically. And if you take them apart, if you cut that pillow block apart, you can actually see like the sealed bearing, there's no way for grease to enter. But the bearing where you have to lubricate periodically, there's actually like there's like an opening in that bearing that allows the grease to kind of get in there and lubricate those bearings up. So I see it all the time. I just wanted to touch on that. What are your thoughts on that?
Well, a lot of times companies, for example, we were in a facility a few months ago. They actually make donuts, believe it or not. So that's a fun place to go into because it smells good and you just want to stand by the oh, it smells fantastic. And I mean, you want to be in the lab because they're tasting it. You want to be in the failure section where well, the donuts are failed because they're fantastic. But half their facility, they had sealed bearings and the other half they didn't. And so what they wanted when we went in there is to get some good lubricant practices. Sealed bearings are fantastic. So I'm a big believer in having it, especially when there's a high dust or high dirt environment. Dirt is one of the biggest problems for when it comes to bearings, especially when you have an open bearing that can be greased. What many let's say manufacturing people will do, even on the outside, they think that over greasing or making sure that grease goes past the seal is good. And in many cases it's not, because the extra grease that's out beyond the seal actually begins to collect dirt. And then that dirt migrates its way back into the bearing, which of course goes back to that original expression I said about antioxidant. It'll make those free radicals form, and then the bearing fails. So bearings where you can grease are very good, but there is a technique to making sure that they're lubricated correctly. And a seal bearing, they tend to be good in these high dirt or high dust environments, but sometimes they always last as long as a bearing that you can control. What they have inside a sealed bearing is sometimes some of the bearings itself will have oil impregnated in them. And as the bearing gets a little hotter, some of the oil will seep out. And it's a really fantastic design. So both have their purpose, in the marketplace, whether it's HVAC or industrial manufacturing, but both have to be used for specific applications.
So what would be so for the bearing that needs to be lubricated, what would be a good practice or procedure to make sure that we're staying on top of that? I mean, we could go with a schedule. We could go based on the manufacturer's recommendations. Like, what would be the best practice there, Sal?
Well, that's a great question, because this is one of the main things that we try to accomplish when we go in. You know, you don't want to sound like a know-it-all, right? You have these maintenance people, they're working very hard. They're trying to run a facility. Some of these facilities have, you know, thousands and thousands of people. And even if it's HVAC people out trying to make sure that their customers are happy, at the end of the day, that's what we do, right? We want to satisfy the customer, and we want to make sure that we're actually providing our own value to them, but also maximizing ourselves. So if you're an HVAC person that owns their own business, you know, you want to spend your time doing things that will provide the most amount of profit. And lubricant is something that's many times misunderstood. So one of the examples I used, but we had touched on, you and I, is when we go in, we try to find out what their maintenance schedules are. And a lot of maintenance people use an expression called shots. So that's a pump of the grease gun, and that's a shot. So you and I might, you know, even though we're professionals, we might view shots as something more fun, especially when you're out in the sun at the beach. But in this particular case, one shot equals a pump of the grease gun. And we'll go in, and we've seen this time and time again where the maintenance schedule, in order to make it simple, they'll say, okay, machine number 1, use 3 shots every month. Machine number 2, use 2 shots every month. And we'll go in and look at the grease guns, and we'll say, hey guys, you're using a sophisticated Milwaukee gun, let's say, or DeWalt gun, and then over here you're using something from Home Depot. And even though it's 3 shots, each one of these grease guns has a different dispensing amount. They'll have sometimes from 3 to 4 to 6 grams. So what we'll do is we'll ask them to take one gun that they seem to prefer, and we'll get a little scale, and we'll take a small either glass or something, and let's determine how many shots gets to an ounce. So if it ends up being, let's say, 10 shots gets to an ounce, we know that there's 3 grams or so in each shot. Now we go and check the bearings, and we'll go figure out what the determined factor is of how much grease really needs to go in the bearing. And you'll find that, for example, with mineral oil-based greases, you really don't want to fill the bearing more than about halfway, because as a bearing gets hot, mineral oil will expand, and they call that thermal expansion. And that, especially if you have it 70 or 80% filled, it's going to go beyond the seal. So once we got them to where they have the one grease gun, and then they know exactly how much goes into each bearing, then we can really do a PM schedule to get them so it's consistent. And I can tell you, Gary, almost 100% of the time, even if they don't buy our products, which we want them to buy our products, but even if they don't, we've already saved them a huge amount of money. And these maintenance people, you know, their job is to do things that are really going to bring value, like replace or rework a gearbox, you know, add an air conditioning system, things that are big money. But having to spend all the time greasing, that ends up, even though it's very, very important, there's a really simple way of making it repeatable and saving the company huge amounts of money.
Yeah, that's interesting about that. The fact that different grease guns have a different output. And I mean, you could be putting way too little or way too much, depending on what grease gun you're using, if you don't know the actual output of the grease gun. Like you said, and if you got like 3 different kinds in the maintenance crib, and I mean, I've worked in many manufacturing facilities, and usually these maintenance cribs are pretty good at with their parts and their maintenance stuff and their routines and stuff like that. But these are little details that a lot of people probably don't know, and this is why we're having this conversation. Now, the other thing about bearings too is that I've seen it, and I've never really done a deep dive on this, Sal, and you could probably talk more about it. Like, I've seen different colors. Like I'll see like some bearings, the remnants, the grease is black. Sometimes the remnants of the grease is like a reddish color or a yellowish color. What is the difference here? Like, what are we looking at?
I love the question. It's a fantastic question. It's one of the things I was going to bring up today. I was going to talk about some of the grease chemistry, but I also wanted to talk about the colors. One of the things we'll do in a facility is we'll ask a loaded question, which and we'll say, you know, which color grease is the best? And you'll get one group that'll say, oh, the black grease because it's got extreme pressure additives and it's going to hold up where it needs to hold up. Somebody else will say, oh, no, the sticky grease because that's got all those tackifiers. Somebody goes, no, the red grease. The red grease is best because it's high temperature. And then you have like a blue grease, which might be thought of as maybe more of a marine or water washout. A lot of facilities we go to, especially when they're using some of the larger electric fans and motors, they'll want to use like a polyurea, which is more like a blue grease. And the actual answer is color has nothing to do with the performance of the grease. And yes, a black grease may have a metal additive in it, which may aid in giving you more extreme pressure. Or maybe the red grease may be synthetic, so it may have a higher temperature range. But at the end of the day, many times the red is just coloring that you're putting in. So when you have a good lubricant, for example, our product's white, and you would never think that a white grease would hold up against a black grease, but our extreme temperature range and our load wear index, which is a total measurement of lubrication, is equal to a black grease. So in this particular case, you'll have a safer food grade grease that holds up to the temperature range, but it's also clean. So you can't always look at that. And one of the things I wanted to touch on with oil, which I did before, was talk about some of the additives. And when you switch over to grease now, you have the same types of additives: anti-wear, anti-corrosion, antioxidants and corrosion inhibitors. But then there are also two additional things that are added to greases. One is a thickening system. So you may have heard of lithium. All right. So there's many different materials that will make a grease thicker. Lithium, sodium, calcium, aluminum complex, silica. So depending on the chemistry of what the overall chemist or company wants to create, they have a thickening system. Now, in addition to the thickening system, they're going to add some kind of, maybe, not always, but maybe a solid additive. So solid additive might be moly, molybdenum disulfide. One might be aluminum. There's zinc, there's graphite. In our case, PTFE, which is more of a polymer. It's not a metal base, but it's still for extreme pressure additive. So the chemistry going into doing these things is very, very important. But they, in many cases, the manufacturer of the greases wants to make something that specifically targets an application. And some companies want to make more multi-purpose, so you can reduce the amount of greases in a plant, like we do, but some want to have very application specific. And the other thing you touched on about the different colors is a lot of times I'll go into facilities, and we go back to that grease gun. They'll try to mark the outside of the grease gun so you know which grease is going to be used in that grease gun. Sometimes they just look at the outside and see what the color of the tip. Is it brown? That's maybe lithium. Is it black? Maybe that's the moly grease. So it's managing all of that, the purchasing side of it, the maintenance side of it, the actual application itself. It becomes a fairly complicated thing, especially if, let's say, a facility has maybe 3 shifts. So these things have to be coded. So I love the question because it's a question we get asked a lot. Good for that one.
I noticed you said your grease is white. So you're saying the tube of super lube that goes into a grease gun is an actual white color? Is that what you're saying?
Yes, actually it's synthetic and it's white, a great temperature range of -43 C, 232 C. So it's going to work in a whole bunch of applications. And what we try to do is, didn't want to totally get on super lube, but we try to simplify.
For sure, man. Like, you're wearing that nice super lube vest, and I know the super lube product is like a multi-purpose, so it can expand or span a wide range of applications. So I'd like you to talk about it just so we know, like, we're covered if we're going to use that grease in like different areas of whatever manufacturing, HVAC, whatever it is, right?
We appreciate that. It's a great product because what we found is when you go into facilities, most of the companies that we compete against are application specific. So you go into a facility and they'll have an extreme pressure grease. They'll have a low temp grease. They'll have a high temp grease. I know in HVAC, a lot of it's outdoors and a lot of it's moisture related. So again, going back to the polyurea grease that has calcium grease, which is moisture related. But if you could, maybe not 100% of the applications, but in 90% of the applications, have one grease you can use that can cover all those, it's going to simplify your day. It's going to simplify the maintenance crew. They don't have to think about which product goes where. I mean, I've been in facilities where they have signage all over. And what we'll do is we'll take the super lube grease and slowly get it to where they can use it in almost every location. There are places where they have flash freezing, where things are very cold. So you need a grease that's slow. We've been in applications where they use what they call winter summer greases. That's pretty popular up in Canada, winter summer greases. You can't use a winter grease. It'll start liquefying during the summer. and then a summer grease will hold a low end temperature range. So at the end of the day, if you can have a safer product that's going to last in those applications, and that's where Superlube works well. One of the things I wanted to touch on that I was going to say before, even about Croyle, is that so many times maintenance people aren't maybe taking that additional time just to do some pre-lubrication. So if you have maybe a screw or a bolt, put some grease around that before you put it in. And it's going to be easier when you have to remove it at that one point. And if you have to remove it and it is frozen, Croyle is a tool. I don't consider Croyle a product. I consider it just another tool that's in your toolbox, just like a wrench or a hammer or something. So it's something that's necessary, because the faster you get that bolt loosened or screw loosened, the faster you can go on to the other things you're doing. So this is where the Superlube grease and the Croyle tend to work well with each other, because they're used on different areas and both have a great purpose.